What's up, you all? My name is Dimesh, and today I'm going to talk about time. So stay with me and watch the video until the end.
Let us consider first what we mean by time. What is time? It would be nice if we could find a good definition of time. Webster defines a time as a period, and the later as a time, which doesn't seem to be very useful. Perhaps we should say time is what happens when nothing else happens, which also doesn't get us very far. So everyone is familiar with time. 60 seconds is 1 minute, 60 minutes is 1 hour, 24 hours is 1 day, and so on. If someone come up to you and ask you to draw time, what would you draw? Clock or maybe calendar? But all those drawing would be just physical representation of passing of time. Earliest time measurement were observation of cycle of natural world using patterns change in day to night, season to season that gives us today's calendar. Through that more precise timekeeping like old times, people use sundial to keep track of time. Then mechanical clock eventually come along to put time in more convenient boxes. When we describe motion, we do so as a function of time, like 100 meter per second, 100 miles an hour. As Einstein theory of relativity tells us, time is not absolute. What do I mean by absolute? In simple language, time passes for everyone, but doesn't always pass for same rate for people in different situations. Time slows down for people who are traveling close to the speed of light or orbiting around black hole. According to Einstein, the distinction between the past, present and future is but a stubborn illusion. Time is one dimension of space-time in special relativity. Suppose you make a plan to meet your friend, you wouldn't give them place without a time. But here is the thing, we live in 3 dimensions world. We can move in all the dimensions in space, like left, right, up, down, forward and backward. But in time dimension, in only one. No matter what we do, the past is past. This is called arrow of time. No matter what you do, time works only one way. You come from the past and you will go to the future. If time is such a fundamental property, it should be in our fundamental equation describing the universe. General relativity describes the behavior of very large things, like galaxies and stars, while quantum physics explains the very small things, like molecules and atoms. So here is amazing thing for you. In big scale, you can easily tell the difference between year 1900 and year 2020. However, in a micro scale, if we look deep down into the bones of the particle that make up the universe, time seems to work and flow in every direction, both forward and backward. The fact that the entropy is increasing is well known. The universe came into being at the instant of the Big Bang. We have the Einstein general relativity that allows us to go back a mere second after the Big Bang. That's as far as we can go. There's no law of physics yet that states that there wasn't time before the Big Bang. We have proofs that says universe is started to expanding since the Big Bang and still expanding. There will eventually be a time where everything in the universe is so far apart from one another that space will eventually be empty. It is possible that quantum fluctuation could cause an extreme random entropy decrease. You know what that means? This could create similar condition like Big Bang and could explain arrow of time and origin of universe. However, in order to understand and answer these questions, we need to unite quantum mechanics with Einstein's general relativity. This would combine quantum world of atoms with stars, galaxies and black hole. This is dubbed theory of everything. With this theory, we may be able to answer and explain why and how the universe came into the existence, and maybe even prove that multiverse exist. Okay, so that's it for today's video. Peace.